Hello, everybody. Welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked chemistry questions both at the high school/university and college levels. So, I'm currently a second year human biology student studying at U of T. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys should check out the description box below. And other than that, we'll get started. So the first question says is how is the enthalpy of fusion calculated? And so basically, as it's stated here, that the heat which a solid absorbs, it is, and then it melts, is called the enthalpy of fusion. So basically, when a solid, and say when a solid becomes a liquid, right, or when it melts, basically melts, it this transformation is called the enthalpy of fusion or heat of fusion. You can say this the state from changing from solid to liquid. By it's called enthalpy. It's called enthalpy of fusion or heat of fusion. Okay, so for example, if you're talking about ice here, let's say ice melts into water. So let's say a solid ice cube melts and becomes liquid water, right? So this transition you can call or the heat basically which the ice in this case absorbs to melt into water. This is called the enthalpy of fusion or heat of fusion. So basically, when let's say for example 1 mole of ice is melted, we find from an experiment that 6.01 kilojoules are needed. You can say that the enthalpy of fusion of ice in this case, so the enthalpy of fusion of ice fusion of ice you can say that is 6.01 kilojoules per mole, and it is normally expressed as this is denoted by the symbol delta H m is equal to 6. So in this case for ice would be 6.01 kilojoules per mole. So this is basically the heat absorbed by the ice when it melts, and this is called the enthalpy of fusion or heat of fusion. And in this case for ice it is 6.01 kilojoules per mole. So this is correct. Question we have here says, what are chemical formulas? Okay, so basically when we're talking about chemistry, we are often talking a lot about chemical formulas. So chemical chemical formulas are a way of representing molecules or compounds. They contain basically the information. Chemical formulas are a way are a way to express chemical compounds. compound, and so they contain information about, so contain like information like number of atoms, moles, in as in the number of atoms slash moles of elements. So basically the proportion of elements in a compound. So for example, let's say for example, for example, for example, given the chemical formula CO, okay, we know that the compound is made up of two elements, right? Two elements, which is carbon and oxygen. And so you can see, so this chemical formula is telling us that we have one carbon and one oxygen, right? So this is what, so basically this is telling us the ratio is, so the ratio is 1 to 1 for, and we can tell this by looking at the chemical formula, which is CO. So for every one carbon atom, there's one oxygen atom. And so we also know that no charge, right? So it tells us if it has a charge or not. In this case, there's no charge. So, and so let's say, and a net charge. Okay. So basically, this is why chemical formulas are very important to represent chemical compounds or substances, because first of all, they tell us the ratio of each element in the case in the substance, and also it tells about the number of atoms or moles of the elements and the overall net charge. Okay, so as they've mentioned here, so solution is correct. Okay, so our next question says, what is the molar mass of nitrogen? Okay, so the molar mass of the element or a compound per 1 mole of the element or the compound. So this is what the molar mass is. Basically, you're saying the mass of the element per 1 mole. Okay, so we say mass of the element, mass of the element or compound or compound pound per 1 mole. Mole of the compound, okay? And so in this case, we're talking about an element, nitrogen. And so nitrogen, the molar mass of nitrogen, since it's just an element, it would be, so you won't really have to add or subtract anything in this case when you're calculating the molar mass. So it is also the molar mass or the atomic mass. I say molar mass. So this is supposed to say molar mass. And we can also add that molar mass, you can say molar mass is the same thing as the atomic mass. but the only difference is the units. Molar mass is grams per mole, and atomic mass is used as AN. Okay? And so basically, from the periodic table, it is given the molar mass and the atomic mass, which is the same thing, is given in your periodic table for each element, but not compounds. So in this case, since nitrogen, so N is a element, right? So it is nitrogen. And so in the periodic table, it shows that nitrogen has a molar mass, of 14.01 grams per mole. Okay, and so this is the answer. So number 4, what is the molality of water calculated? Okay, so you don't really have to calculate it since it is a constant value, which is 55.510 molars, or molality basically. So this is how it usually works. That let's say, for example, you have 1 liter of water. 1 liter of water is at 1 liter. So let's say you have 1 liter of water. So at 25 degrees Celsius, the density of water, okay, the density of water is 0.9970749 grams per milliliters. So the mass, so you can calculate the mass from this if you recall. So the mass is equal, so if you recall that our density is equal to mass over volume, our mass is equal to density times volume, and so in this case you just multiply the density, which is 0.9970749 grams per milliliter, and our volume in this case is 1 liter, but we have to convert the units here, so you would have so you would basically convert this, so you would have 1 liter of 1,000 liters, and so you would basically say, so basically the mass would be, so you would want to first so you would convert this, or you would want to convert this into kilograms, right? So you would have one milliliter over liter. So you would basically multiply multiply this by 1,000, and you would basically get, to multiply this out, you would basically get 0.99 times 10 to the power of 3, 0.99 times 10 to the power of 3 kilograms per liter. But we could also say, since we don't, since, or sorry, it's just, this should be 0.99 times 10 to the power of 3 kilograms per liter. And so this, so since we have this, or sorry, this, yeah, so since we have, this is our density again, I guess this should be density. Our new density would be this. So density is equal to V. Okay. So we want to convert this into kilograms per liter, since we're working with liters of water, right? 1 liters. And so the number of moles, to calculate the number of moles, we would just do the number of grams. So the number of grams time divided by your molar mass. So we can basically say that, so the amount, so with the amount of water, the number of moles, so the number of moles, so you can say is, so n, so let's say n is the number of moles, is equal to mass over molar mass. And so since our mass in this case is, it would be, so we would work with grams, since our molar mass is grams per mole. So we would convert this into grams, and it would be, you just times that by 1,000. You would get 997.0749 grams per, and so your since water is H2O, right? The molar mass of H2O is, so the molar mass of water so it would be the molar mass of water, molar mass of hydrogen, so 2 hydrogen atoms, plus molar mass of your oxygen. This is given in the periodic table, and this is around 18.0148 grams per mole. Okay, so we can just put this into our equation right here, and we get, so if we put 18.0148 grams per mole, all grams would get cut out, and you basically get 55.348 for 8 moles. Okay, so molality. So now we're trying to find molality. That's the actual question. So molality, or m, lowercase m, is defined as the number of moles of solute per kilogram of solvent. Per kilograms of solvent. So we can basically, so our solute in this case, So the solute in this case would be water, the number of moles, since we're just working with water, and our solvent will also be water. So molality would be, so the number of moles of water over the kilograms of water, right? So of water. So since our moles is 55.348 moles, this is all over our kilograms, so it's gonna be 0.9970749 kilograms, and you get 55.510 molarity. Okay? And so this is your answer, and this is what they've got. So this is correct. Yeah, our next question says, what is the molar mass of helium? So as we've previously discussed, that molar mass is defined by is basically the mass of a given chemical element or chemical compound in grams divided by the amount of substance in moles. And so the molar mass can be computed using a periodic table. It is actually given in your periodic table, the individual molar masses of elements, but not compounds. And so when you're dealing with compounds, you basically have to add you basically have to add so for compounds, write this down, for compounds, to find the molar mass of compounds, you would have to add all the individual individual elements molar mass. Okay, and then that will be your answer for that one compound. But however, since if we're dealing with just one element, and if it says to find the molar mass of one element, it's actually given in your periodic table. And so for helium, since helium is a noble gas, is a noble gas, and so it is located in period 1, group 18, and it has a molar mass of 4.0 grams. Okay, so also I would want to mention molar mass is basically the same thing as your atomic mass unit of a element. And so if you guys recall, atomic mass unit is calculated by the number of protons plus the number of neutrons of an element. And so this could be the same thing for your molar mass. And so since so helium has a number, so helium has 2 electrons, so that means helium has 2 electrons, right? 2 electrons. That means that it has 2 protons as well. And in most cases, your number of protons will equal the number of neutrons, so you would also have 2 neutrons. And so this is how you get your atomic mass and your molar mass, basically. But your atomic mass unit is in AMU, molar mass is in grams per. So this could be, and so that's how you could get, that's how you can find the atomic mass and the molar mass. But this is also given in the periodic table. Okay, so our next question says, what is the molar mass of mercury oxide? Okay, so in this case, so mercury oxide is HgO, mercury oxide. Mercury oxide. Okay, so the chemical formula for this is HgO. And to compute the molar mass of this, we would have to first break this down into 2 elements. In this case, we have 2. And so we will first find the molar mass of mercury and then the molar mass of oxygen, and you would add that up. And so the molar mass of mercury is given in the periodic table and has a molar mass of 201 grams per mole. And the molar mass of oxygen is 16. So the last step would be to add these 2 numbers together, and you would get 215. So this is 1 atom, or like 1 mole of of mercury oxide. If there was 2, you would just multiply this by 2. If there was 3, you would multiply by 3. This is correct. So next question says, how do you determine pH from pKa? Okay, so when we're talking about pH, we're talking about acids, bases. And so the pKa is a method that can be used to basically measure the strength of an acid or how acidic a compound is, if it's an acid. So the pKa is the pH value at which a chemical species will accept or donate a proton. So in this case, the lower the pKa, the stronger the acid. So lower pKa leads to a stronger acid. And so you can see this is inversely proportional to each other. And so the acid would have the greater ability to donate a proton. So greater ability to donate a proton, a hydrogen ion. And so to determine pH, given the pKa for a monoprotic acid, so that is just a acid that has basically one hydrogen, a proton, basically. And so for example, let's say we have an acid, and let's say it is reacting in aqueous solution, and so it dissociates into it dissociates into a proton and the conjugate base. So this would be aqueous. And so if you're dealing with a buffer in this case, then you're dealing with a weak acid. So buffer is weak acid. Okay. Weak acids, and so therefore the Henderson-Hasselbalch equation can be used to determine the pH, and so that equation is denoted by pH. That is denoted as pH is equal pH is equal to pKa plus the log of A, your conjugate base, and your acid concentration. And so otherwise the acid dissociation constant Ka must be used. Okay, and so in order to determine pH, first we have to find the concentration of our H plus ions. So the pH. So when we're dealing with acids, we have to we have to first determine the concentration of our protons or the hydrogen ions. And so in contrast to that, when you want to find the pH of your bases, we have to use the concentration of our hydroxide ions. And so we take the negative log of your hydrogen ion. And so the value of the dissociation of the acid dissociation constant can be derived from the pKa. Okay, so this is how you get the pH of your the pH of the concentration of the hydrogen ion, and then you can derive the Ka, which is the acid dissociation constant, from your pKa by taking 10 to the power negative pKa, the negative pKa value. And so basically for strong acids, the pKa, right, as you mentioned, would be small, would be really low, and so it would be less than 1. So your Ka will be greater than, as we said that this is inversely proportional to each other. And so for strong acids, since they dissociate completely in aqueous solution, you can basically say since strong acids dissociate completely in aqueous solution, we can basically say that our hydrogen ion concentration is equal to the concentration of our acid. Okay, which means that our pH can be calculated by also taking the negative log of our concentration of our acid. Okay, and so this is how you find how you find the pH from pKa and from the concentration of hydrogen ions and the acid. So solution. Next. Says, what is the Lewis structure of um, sulfur dichloride? So, okay, so a Lewis structure is basically a representation of the electron distribution around the atoms of the compound. So it is also an important tool to protect the number and type of bonds that can form around the atom. And it also helps predict the geometry of the molecule. So whether it's a tetrahedral, a triagonal, planar, or and stuff like that. So the following steps are needed to draw the Lewis structure. And so step one is determine the total number of valence electrons. So number total valence. In this case, we're working with sulfur dichloride, and so sulfur has a valence electron, has 6 valence electrons, and we have fluorine, and in this case we have 2. So one fluorine atom has 7 valence electrons, and since we have 2, we would times this by 2, and we would have 14 valence electrons. So in total, we have, I'll just write this. So 2 fluorine atoms, we would have 14 valence electrons. So if you add this up, we have a total of 20 valence electrons in total. And so this was step 1. Step 2 is to determine the number of electrons needed for bonding. So number of electrons needed for bonding. And so since there are 2 fluorine atoms, the number of electrons needed for bonding is 4. So in this case, since there are 2 fluorine atoms, we would need 2 bonds. We need 2 bonds, hence 4 electrons. Okay, and now step 3 is to determine the number of lone pair electrons. Okay, so step 3, determine lone pairs. And so the remaining electrons are used as lone pair for central or terminal atoms to achieve an octet to finish the Lewis dot structure. Lone pairs of electrons for octet. So basically, so let's count the lone pairs, how many lone pairs you would have. So in this case, to calculate that, so electrons needed for lone pairs. So this would be basically the total number of electrons that we have, which is 20, minus the bonding electrons, which is 4, and you have 6, right? And so, so the total number of lone pairs, though, so total number of pairs of lone pairs, you would have 8, right? And so now so using these three information, we can now step 4 would be to draw the Lewis structure. This structure. So since we said that we would have two bonds, since we have two fluorines, we would have two bonds. And so you can imagine that our central atom in this case would be sulfur, and it would bond to two fluorines. Okay, so fluorine, fluorine. And since we said we have 8 lone pairs, so we would now so let's first give it to our terminal atom here, which is fluorine. So fluorine has 7 valence electrons, and since it's bonding with 2, it would have 6, or not 6, it would have 4 in this case, since it's sharing the other 2. And in this case, sulfur would have 2 lone pairs. So in this case, we have 1, 2, 3, 4, and we would need another 4, which would be 4, right? So 1, 2, 6. And so the total number of lone pairs in this case, and so the other ones are bonding. So this is the total number of, so this is, I guess, fluorine would have 3 lone pairs, and so this is how you would draw the Lewis structure of SF2. So you can count the number of valence of lone pairs: 1, 2, 3, 6, 7, 8. So we have 8 lone pairs, and 2 of them are bonding. 4 of them are bonding, and that's how you have a total of 20 valence electrons. Okay, so this is correct. Okay, next question. Here it says, what is the molar mass of sucrose? So sucrose is a type of sugar, and it has, so to find the molar mass is very crucial to know the chemical formula. And so the chemical, I'll say sucrose, has a chemical formula that is C12H22 So this is the chemical formula for sucrose. And to now find the molar mass, we have to do, so molar mass of sucrose is, so we would break this down into 3 individual elements in this case. So we have, the 3 elements are carbon, hydrogen, oxygen. We have, so the molar mass of, let's break this down. So first we have carbon, and we have 12 carbon atoms. we would add this to the molar mass of 22 hydrogen atoms. And lastly, the molar mass of 11 oxygen atoms. Okay, and so the molar mass of one carbon atom is 12.01 grams per mole, and we have 12 in this case, so you would multiply this by 12. And so the next step goes, so the next would be hydrogen, and so for one atom of hydrogen is the molar mass of it is 1.01 grams per mole, and we have 22, so you would times this by 22. You add this with, and then you would add the last one, which is oxygen, and one oxygen atom has a molar mass of 16 grams per mole, so we would say 14.0 grams per mole, and we have 11 in this case, so we would multiply this by 11. Okay. And so if we further evaluate this, we would get, so 12 times 12 is 144.12 grams per mole. Add this with 22.22 grams per mole, right? And then you multiply 16 times 11 and you get 176.0 grams per mole. And you would just add all these three numbers together, and your answer would be 342.34 grams per mole. Okay. And so the molar mass of sucrose, is 342.34 grams per mole. Okay. And so this is correct. Okay, now our next question says molar mass. So to find the molar mass of benzoic acid. So to do this, we would first have to know the formula for benzoic acid. And so let's say benzoic acid has, so the chemical formula for this is C7H6O2. So you know it's an acid because it has hydrogen, and in this case, it also has a oxygen. So to calculate the molar mass, we would now break this chemical formula down into three individual elements. So you would have molar mass of C7H6O2. We find the molar mass of these three individual elements, and so the molar mass of 7 carbon atoms plus the molar mass of 6 hydrogen atoms plus the molar mass of 2 oxygen atoms. So the molar mass of one carbon atom is 12. So since we have 7, we would do 7 times 12 to 1 grams per mole. And then since we have 6 hydrogen atoms in this case, we would multiply this with its individual of 1 mole of hydrogen is 1.01 grams per mole. Then you would add this with the molar mass of 2 oxygen atoms, and in this case it would be 2 times 16. So grams per mole. And then if you do the math here, you get 84.07 grams per mole, and then plus 6 times 1.01 is 6.06 grams per mole, and then multiply 2 times 16, which is 32.0 grams per mole, and you would add all these three together, and we get 122.13 grams per mole. And so therefore, the molar mass of benzoic acid is 122.13 grams per mole. So this is our next question. Says the molar mass of acetic acid. Okay, so acetic acid has a chemical formula of, it's given, which is CH3COOH. And so now let's find the molar mass of acetic acid, which is CH3COOH. And now, so let's first break this down into its individual elements. And in this case, you can see we have carbon, hydrogen, and oxygen. So let's say molar mass of, in this case, we have 2 carbon atoms. And so we would say, let's say 2 carbon plus we have molar mass of, we have 4 hydrogens, and we would add this with 2 oxygens. Molar mass of 2 oxygens, not 20. And so the molar mass of 1 carbon atom is 12.01 grams per mole, and we have 2, so you would multiply this by 2. Then we would add this with times 4. So 1 atom of hydrogen has a molar mass of 1.01 grams per mole. We would multiply this with 4 since we have 4 in this chemical formula. And lastly, the molar mass of 2 oxygen atoms. So you do 2 times 0. So this is the molar mass of one oxygen atom has a molar mass of 16.0 grams per mole, and 2 would have 2 times that. So now let's further evaluate this, and we get 24.02 grams per mole. And then you add this with 4.04 grams per mole. And lastly, you would add this to the math here, and you get 32.0 grams per mole. And the last step is to add all these 3 numbers together, and you would get 60.06. Okay, and so the molar mass, so we can say the molar mass of acetic acid, which is CH3COOH, is 60.06 grams per mole. And this is what they've got. So this is the correct solution. Okay, and so basically that was the end of our session. If you guys like this Q&A, please subscribe to the One Class channel. Comment, share this video, and if anyone has any personal questions or needs one-on-one tutoring services, you guys could check the description box below and follow the links to ask questions. Other than that, I'm Shanjida, and I'll hope to see you guys soon. Bye bye.